continuing on in our science book. We're starting a new chapter. This is chapter 4. We're talking about forces and simple machines. So before we could talk about simple machines, we definitely have to understand what a force is. Now, we're going to talk about 6 different vocabulary words in this chapter. And they're on the board. And let's go ahead and you can repeat at home. And throughout this lesson, we will talk about what each one of these mean. So the first one, force. Second, gravity. Third, friction. And these two are connected to the word force. All right, and we'll explain that a little bit later. Over here, motion. Fifth one, work. And then the last one, energy. And then we have to think. We might know some of these words already, but we have to think of it in a scientific manner. Okay, we're on page 74, and this lesson is through page 77. This is lesson 52. All right, so follow along as we read, and I'll explain as we go. But before we read, I want you to do something for me, and you could try this out at home. I want you to find any wall, that's really strong, okay? And put both of your hands on the wall, and then for maybe 10 seconds, I want you to push as hard as you can, okay? So put your hands on the wall, and with all your might, with all your effort, push on the wall, okay? You can stop the video and go do that right now. Well, if you're back and you tried this, I want to ask you a question. Did the wall move? I hope you said no, unless you have superhuman strength. Probably the wall did not move. So you used a lot of what we call force. You're pushing extremely hard on the wall, but since the wall didn't move, you didn't do any work. And I'll explain why in just a little bit. Okay, let's follow along, please. Suppose a young child asked you to give him a ride in a wagon. How would you move the wagon? You can grab the handle and pull the wagon, or you could push the wagon and allow the child to drive. Whether you pull or push, you're providing a force to move the wagon. A force is a push or a pull. To move the wagon with a child aboard, you apply or use force. You put forth an effort to cause the wagon to move. You apply forces on objects all the time. You pull a brush or comb through your hair as you get ready in the morning. You push your pencil across your paper as you write. You pull on the sleeves of your coat as you put them on. Other things also apply force. Or apply forces. The wind's pushing against the kite causes it to fly. A boat's propeller pushes it against the water to cause the boat to move. A magnet pushes a piece of iron toward itself, or attracts it. Gravity and friction are 2 forces that we experience every day. Okay, so there's that word force. What is a force? It is a push or a pull. One more time. What is a force? A push or a pull. And you can apply the force, or like it mentions in here, when you're flying a kite, when that wind is blowing, that's pushing against the kite, that's a force. When the motor is turning in the water, that's pushing the water away from the boat, that is a force being used. When you put your coat on, comb your hair, all of those things, you're using force. And you probably don't even think about it, but you're using force all the time. It's a push or a pull. The best, or probably one of the most fun way to experience force is playing with magnets. Now, if you if you have 2 magnets and you put S and S, or South Pole and South Pole together, it won't come together. It will repel each other. But you do opposite, what will it do? It will attract. So either way, that's using a force. So if the opposite ends are connected, it attracts. It's pulling each other toward each other. But if you flip it around and it has the same poles facing each other, it pushes or uses a force. It pushes away from each other or repels. So magnets are very fun to understand force. And we're going to learn about magnets and magnetism in the next chapter. But there are two forces it mentions in our book. Gravity is one of them, and that's up on the board, gravity. And we also use friction all the time. Let's talk about gravity. On the earth, gravity is the force that pulls all objects toward it. This force pulls on objects without touching or having contact with them. Rain falls to the earth because of gravity. When you jump, you return to the earth because of gravity. So if I have my eraser, I'm going to use the eraser. If I hold it up in my hand, can I tell this eraser or to stay here? If I let it go, will it stay in the air if I command it to do so? Okay, eraser, stay. No, it didn't listen very well, did it? Or maybe I didn't say please. Maybe if I'm polite to the eraser, maybe it'll listen. Okay, eraser, can you please stay in the air when I let you go? Why did it keep falling? Why? Because the Earth's gravity pulled it toward the center of the Earth. Gravity. And we all experience gravity every day. And it's a good thing that we have gravity, otherwise things would not stay on the Earth. It would be floating around. Gravity is a force. Why? Because it's pulling objects to the Earth. And a force is a push or pull. We talked about gravity in the last lesson when we went to the moon. Okay? All right, let's talk about friction. Friction is the force that resists the movement of objects against each other. Friction occurs when one object is in contact with another. It can cause a moving object to slow down, speed up, or stop. You experience friction when rubbing coarse sandpaper on a rough piece of wood. The sandpaper does not move easily. The wood resists the movement of the sandpaper. As the wood becomes smoother, you can move the sandpaper more easily because there's less friction. Friction can be helpful. Without friction, objects would slip and slide. Look at the soles of different shoes. The friction of the ridges on athletic shoes causes the shoes to grip smooth surfaces. A basketball player can run and stop on a polished gym floor without worrying about slipping. Other shoes may have smoother soles or the bottoms of the shoes. You may need to walk carefully to avoid slipping them when wearing these kinds of shoes when walking on smooth floors. Okay, so another form of force is friction. Let's say that word again, friction. Now you might think, friction, it resists movement. Well, that doesn't sound like a good thing, but actually it's really, really important, and God was very wise to create friction. So I'll give you an idea what friction is. You can take your hands together, place them together, and start rubbing really, 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 really fast. Okay? And friction is when two objects rub together. All right? So when you rub really fast, what do you feel? Well, it begins to feel warm, right? Now, think about this. When you're walking, do you keep falling down? Do you keep slipping like there is oil all over the ground? No, hopefully you don't. Why? Because the bottom of your shoes is rubbing against the floor, keeping you from falling. Can you imagine if there was no friction trying to go downstairs? You would just slip and tumble and fall and probably keep going unless you hit something. Friction is really, really important because, let's say we're running and we don't have good friction, we wouldn't be able to slow down very well. Or driving a car, if it's icy, there's very little friction and it could cause the car to slip and slide, and that can be dangerous. Also, think of the car again, we want to speed up. If we press the gas, that friction against the road and the tires against the road causes that car to move faster. What what if the tire was really, really smooth and the road was really smooth? Do you think you'd have good friction to get the car to move? No, probably not. So friction can be very good. Without friction, many things wouldn't stop. Let's say you're throwing a baseball. You throw it in the air. If there were no friction in the air particles, it would just keep flying and flying and flying and flying. Now, yes, gravity does pull it down eventually, but it would go so far away, and you'd always have to run after it if there were no friction in the air to get it to stop. So friction is a good thing. It resists or makes motion want to stop, okay? Or that movement, it makes movement want to stop, or an object to stop moving. And friction, remember, is a good thing. So gravity and friction are two kinds of forces that we use every day. Let's look at page 76, okay? Motion. An object that is not moving is at rest. So that would be something good to highlight. Its location is called its position. So let's say I have my eraser right where it is. That is its position. Okay? An object will stay at rest until a force causes it to move. Motion is a change in position. So let's say I have my eraser, okay, and it doesn't stay up very well. Okay, so it's not moving, it's at rest, but if I apply a force to it, it moved or had motion. It changed its position. This is the old position, this is the new position. Because of force, I added a force to it, a push, it moved to a new position. Motion is a change in position. Change in position. Several things need to happen for motion to occur or happen. The applied force needs to be greater than the force of gravity or friction. The motion also depends on the mass of the object being moved and the amount of force put on that object. Suppose you want to push a wagon with one young child in it. You can easily overcome the friction to put the wagon in motion. But if two or more children and their dog climb into a wagon, you will have a harder time moving it. The full wagon has a greater mass, we learned about mass in the last chapter, than the wagon with only one child in it. The greater mass requires a greater force to move it. Okay, so you can think about this. If you want to try this at home, maybe if you have brothers and sisters and you maybe have a bike and you're sitting on the bike and you're pedaling, you're using a force to push those pedals. Let's say your brother or sister gets on the back of your bike. Do you have to push harder, or is it going to be easier to push that bike, to push those pedals? Well, if you said harder, that's correct. Why? You have more mass on your bike. So more mass means more force. Let's say that again. More mass equals more force. Okay? More force. And that there's a picture in here that gives you that example. The top one, there's only one girl in the wagon. The bottom has three. And you can see he's sweating a lot more with the 3 children versus the 1. Let's keep going. We use the word work to describe many activities. Scientists, though, have a specific meaning for work. And we kind of talked about this at the beginning. Work is done when a force moves an object over a distance. You use energy when you do work. Energy is the ability to do work. All right, so that word work, we have here motion, change in position, and then work. All right, so we have things like homework and housework, and yes, those are all classified as work. But according to science, in order to have done any kind of work scientifically, a force moves an object over a distance or a space, okay? So remember when you tried pushing on the wall? Did that wall move? No, you used a lot of force. You got the first half of the equation right. But did the object move? No. Did you do any work? No, not according to what our science definition is. So I have my little eraser, okay? Here's its position. It's at rest right now, meaning no force is being put on it. And what do? I added a force and it changed its position. Did I just do work? Yes, a little bit of work. It wasn't very hard to push it, but I did do work. Why? Because the object moved a distance when I added force. Okay? Now, in order to do any kind of work, energy is always used. The energy is the ability to do work. And things like cars, they use energy. The gas that you put in it does little explosions in the engine and causes energy to move all those little parts inside, causing the motor to move and then the car to move. So it's always using energy. Your body uses energy. If you had very little energy, you would not be able to move. You would be very weak. Many things, living or non-living, use energy in order to do what we call work. Okay? When you push, let's keep going. When we push or pull a door open or closed, you are doing work. You are using a force to move something. You are also doing work when you wash the car or mow the yard. However, suppose you try opening a door without turning the knob or the doorknob. You can push or pull as hard as you can, but if the door doesn't move, no work has been done. Scientists measure work by measuring how much force it takes to move an object and how far the object moves. So, how much force and distance. Force and distance, and we can measure work. The amount of work you do depends on how much force you use to move an object. Suppose you have to move 2 boxes the same distance. So we know the distance, okay? One is a 25 kilogram or 55 pound box of books. That seems pretty heavy. And the other is a 3 kilogram or 6.6 pound box of packing peanuts. Because the box of books has a greater mass, and you can definitely tell because it feels heavier, it has greater mass. It means that the particles are closer together, even though it has the same volume. We talked about that in the last lesson. It might have the same volume or take the same space, but the particles in that matter are closer together. It has more mass. Okay? Because the box of books has greater mass, it will require more force to work it. Remember, we mentioned that before. The greater the mass, the more force needed to move it. This means that you will do more work and use more energy moving the books than you will the packing peanuts. The amount you work also depends on how far you move something. There are some books on the floor to put away. You can put them on a shelf that is 0.25 meters or 10 inches high, or one that is 1.5 meters or 59 inches high. Placing them on the shelf that is 1.5 meters high would require more work because you would move the books a greater distance. So it doesn't just matter how much force you're using, it also you're measuring how much did you move, okay? So let's say the books are the same mass, okay? But you're putting one in a short distance and the other one, you're going to the top shelf. You did more work with the second one. Why? Because you moved a greater distance. So when we're measuring work, you have to remember not only mass, okay, or, you have to remember how much force you used, and that depends on the mass of the object, and then how much distance did you move, okay? All right, so go ahead and do the 2 questions on page 77, and you can also practice in your activity manual on page 60 about what we learned about forces. I will see you next time.